Hello and welcome to lesson 2A on inductive and deductive reasoning. In this lesson, you're going to learn how to classify different types of reasoning as inductive or deductive and compare the two kinds of reasoning to tell which creates a stronger argument. So what is inductive reasoning and deductive reasoning? Well, I think the best way to explain that is to look at different characteristics of the two of them and then come to a general conclusion. Inductive reasoning is based on observing patterns in specific events, whereas deductive reasoning is based on definitions, postulates, properties, theorems, and other known quantities. So basically, inductive reasoning is based on things that you can see and do, whereas deductive reasoning is based on things that we already know are true, so known truths. So inductive reasoning moves from observations of patterns to create a formal or generalized conclusion that may or may not be true, whereas deductive reasoning moves from known information to writing down a logical argument that arrives at a specific conclusion that is also true. So basically, inductive goes from one or two instances or observed patterns, a couple of things that you see, to make a general conclusion, whereas deductive reasoning goes from something we know is true, a big overarching rule, down to make a specific argument. So they're kind of opposite in structure. This one goes from small to big, this one goes to big to small. Inductive reasoning is most useful in developing a conjecture or a hypothesis. So a lot of the times when you're in a science class and you're writing a hypothesis about something, you're basing that on some things that you have seen and are trying to reach a broader conclusion. Whereas deductive reasoning is more useful in proving something to be true always. Inductive reasoning will not always lead you to a valid conclusion. It doesn't guarantee the truth of a conjecture, but it does sometimes provide strong support for that conjecture. Whereas deductive reasoning always leads to a valid conjecture, given that your assumptions are true. So let's look at some examples so y'all can see what this really looks like. So you observe for the last 5 of 6 weeks, the school cafeteria has served cookies on Fridays. Since tomorrow is Friday, you conclude that the cafeteria will serve cookies. Well, this idea that you've made observations for 5 or 6 weeks and then you draw a more generalized conclusion, you're starting with a pattern you observe and you're arriving at a bigger conclusion that they will serve cookies. This guy must be inductive reasoning because he goes from your observations to a bigger conclusion. Since your lowest grade in geometry on any assignment or test is a 90, you conclude that your average grade in geometry class is an A- or better. Well, how averages work is a known fact. It's something that we know for sure, that we have rules for, that mathematicians have proven. And so if you know that all of your grades are a 90 or higher, you're guaranteed for your average to be an A- or higher. This is all known stuff. So this is deductive reasoning. It has to be true and is deductive reasoning. One of your car's tires is inflated to 40 psi. Since the side of the tire rates the maximum tire pressure is 35 psi, you conclude that your tire is overinflated. Well, this right here, you have a maximum tire pressure. You know that that's as much as that tire can take. And you have inflated it past that point, so you know that your tire is overinflated. This is definitely deductive reasoning because it's based on some known facts. It's based on things that we know for sure to be true. And the parish volleyball team has won their last 5 matches in less than 4 games. You conclude that they will win their next match in less than 4 games. Well, while clearly the parish volleyball team is truly awesome in this instance, we have no guarantee that they're going to win their next match in less than 4 games. This is your past observation. This is something that's happened in the past. While you may try to draw a general conclusion from that, and you can probably guess that they're likely to do well, you don't know for sure. They may come up against a team that's that's very much at a higher level than the teams they've played in the past, so you don't know for sure they're going to win their next match in 4 games or less. So this is inductive reasoning, because it's based on your own past observations. So Chris and Andrew both solved the problem 10x equals 4. Andrew's answer is 0.4. Chris's answer is 0.4, while Andrew's answer is 2/5. You conclude they are both correct. Well, how we simplify a fraction, either making it a decimal or leaving it as a fraction, is entirely a known fact, a known quantity. You know that 0.4 and 2/5 are the same quantity because you went through middle school math and you learned that. So this is clearly deductive reasoning. All right, let's look at some other examples. We're now going to use inductive or deductive reasoning to draw appropriate conclusions. So we are assuming that these are all facts. Every time Caroline passes the ball to Cass, Cass passes the ball to Fallon. Every time Fallon receives the ball, he shoots a basket. Caroline passes the ball to Cass. What can you conclude? Well, you can conclude this chain of events is now set off. Caroline passes to Cass, Cass passes to Fallon, Fallon shoots a basket. So if Caroline passes the ball to Cass, we know that Fallon will shoot the ball. If this is true, if these are our true assumptions, we know that we're going to end up shooting the ball. North Point Bookstore sells rare books. Susan has several rare books. What can you conclude? Well, only thing that we know for sure is that North Point sells rare books. We do not know that every rare book out there comes from North Point. So we actually can't conclude anything. We do not have information on all rare books, just books sold at North Point Bookstore. If you had concluded that Susan had bought her book from North Point Bookstore, you would have been using inductive reasoning by drawing an assumption about all rare books. And if you grew up in a town where there was only one rare book seller, that's a likely conclusion you would have come to. However, it would be an invalid conclusion. No conclusion is possible in this instance. All right. People with red hair sunburn easily. People who sunburn easily wear sunscreen. Karen has blonde hair. Deduction, Karen doesn't wear sunscreen. Well, this is a lot like the North Point question. We have facts about people with red hair and sunburn and people who sunburn easily wearing sunscreen. But we're told that Karen has blonde hair. That's a completely different category of which we have no information about. So even though Karen has blonde hair, we don't know about her sunscreen use. We don't know if she sunburns easily or not. So we can't draw any conclusion about her sunscreen use. So we have information about people with red hair, but we do not have information about people with blonde hair. So we cannot draw any conclusions about Karen and her sunscreen use. All right, guys, that's the end of lesson 2A. Thank you very much, and take a look at the MML.